everyone, thanks for watching laurieWIRED, and in this video we're going to be continuing our analysis of the BPFDoor Linux Backdoor malware. In the previous video we found some initialization code where it was making sure that it was being run as root and waiting until it had those root capabilities, also potentially setting some environment variables and changing a file name. So in this video we're going to be trying to find the malicious portion of the code, so we're going to take a look at that last function that we found in our Ghidra analysis and see if that contains any more of our backdoor malware behavior. So let's jump right into it. I'm going to open up my Ghidra one more time. And let's open up our project. All right. That looks like where we left off. Let me see if this is our main process. Yep, this is our main. Okay, so this top part here, we saw that it was doing some setup code, so it was waiting until it was running as root probably. So let's look at this function right here and see what this has now. So I'm going to double click. And this looks like a decently sized function. All right. Looks like we're doing some socket connections. Hey, that's really exciting. So that is potentially part of our backdoor behavior, and it looks like we're receiving from a socket as well. So let's start just kind of from the top, I think, and name some of these variables and just see how it goes. Okay, let's see, local 28. This looks like we're initializing a pointer to this. What's this? Looks like we're getting the address of this variable right here. I don't think we have any other references that we're setting it previously. Okay, yeah, I don't think so. So we're taking this, and I think we're doing some manipulation right here in this for loop. So what is this doing? What is this variable? Okay, this is just declaring an array of 30 characters, so a new string. Let me highlight that so I can find it again. And then it looks like we're starting. This is going to be our counter, so let me rename that var counter. And it's going through and we're setting this string equal to the value of this string. I'm not sure what was in this string though. Let me see if I can find what was referencing it, if anything set it. Okay, where was our address that we're currently at? 402. I think that's our current location. Nope, this is all just referencing the same spot. That's interesting. Okay, so it doesn't look like we have anything put inside of this string. I'm gonna move on from that for now. I'm not sure why we're copying this when it doesn't look like we've done anything to it. Unless one of our cross-references didn't get automatically labeled in our decompilation, so maybe that's what's happening and this has actually been set. Let's move on and look at our socket portion. This looks really fun. What is this? htons. I'm gonna look this up in the man page. Linux man htons. Did I say that right? Yes. Okay, let's look at our man page. Converts the unsigned short integer, host short, from host byte order to network byte order. So this looks like it's doing some setup for our socket connection. Okay. I'm gonna name that. Let's call this var. Okay. And this looks like it's making the socket connection. Let's just quickly take a look at what we're looking for in our socket connection. What are the arguments? Let me just pull up my previous tab, if it works. Okay, so int domain, int type. Okay, that's going to be the protocol is the last argument. That's fine. Returns a file descriptor that refers to that endpoint. The domain is going to be the domain that it's communicating with, which is going to be this right here. Okay, so let's say var. This is going to be our socket connection. And then it's seeing if that socket connection was successful, I'm guessing right here. So var socket is less than 1. Or var socket setscokopt equals -1. So if that's not successful, then it's just going to return. Otherwise, it looks like it's going to do the actual communication with the socket. Let me see what this setscokopt is doing that's different. So it's taking our socket as a an argument. Let's try this. Shall set the option specified by the option name at the protocol level. Looks like it's just setting some socket options. I don't really care too much. Moving on. Wonder what this argument is though. Just looks like pointing to a hex number. Not too super interesting. Okay, I'm gonna move on to this part since I think this seems more interesting. This looks like just the actual setup code for the socket. Okay, memset local. And then this looks like it's gonna be, I'm guessing, the buffer that's gonna be receiving the response from the socket connection. So let's look up our receive from. Okay, so this is receiving from the socket that it's successfully connected to. And receives the data. Yep, exactly what we thought. So this is going to be the buffer that's going to be receiving the response from that socket connection that it's connecting with. Looks good. Oops. So I'm gonna label this buffer right here. So we were in the receive from. Yeah, still the second argument. That's fine. So let's label this, and we'll do this. Var socket response. Nice. Okay. And that looks like it's just allocating the size for the socket response. Okay. This is our do while loop. And then this. Let's rename this variable. It's going to be var. This is the return value of receive from. I think the return value. Where's our return value? Return value returns the number of bytes received or -1 if an error occurred. Okay, so I'm going to say receive successful, since this is just basically saying whether this was successful or not. And then this is just copying that. Copy, receive, successful. And setting a couple local variables. Not super sure. Let's continue on. Okay, I'm moving on. This isn't looking super interesting right now. Again, wait PID, and then it's forking itself. But it looks like we've got, oh, okay, we've got a lot going on down here. I'm gonna move to this portion of the code right now. Okay, so it's trying to fork itself, and then it's checking to see the fork value, let me see, L. We're gonna call this var fork. Looks like we've got a few strings up here. Maybe just one string. Let me see if I can label this. Wonder if this is referenced. Yep, this is referenced. So let me see if I can fix the type of this. Okay. We've got 28 characters, so it's a 28 character long string. So I'm gonna do retype. And then let's make this 28. Okay, that fixed it. User /lib exec /postfix /master. Okay, let me see if I can copy this. And we'll put it inside of a comment on top of this so it's easier to read so I don't have to read it funny. Okay, let's do a little bit of magic here. With our regular expressions. Okay, dot star. We'll make sure we're in regular expression mode. We'll replace it with nothing. And then let's replace these. Not sure if that got my new line right there. Oh, yep, looks good. And then of course the null character is going to be the end of the string. So this right here is our string. Cool. Let me insert a comment. Right here. Looks good. Okay, so that's our actual string. Let me rename this variable as well to match that. So we'll do var. I'm gonna call this lib exec postfix master. And then maybe I'll prefix that with a stir so I know this is a stir. Okay. So we're checking the length of the command line arguments. Arg v len, let's just call that. Okay, and then we're copying this into this argv variable, which I thought this was our first, these were our actual command line arguments, but it looks like we're using this as a destination string. Out of curiosity, let me go back and make sure I didn't label that wrong. Oh, okay. This takes no arguments, and yet this is labeled as our argument vector. Interesting. Let's see. I mean, you could use it if you wanted to. Something weird. So setting a string. And then putting some characters into that string, getting the length of the string again. Passing this local 40, which was what? Did we ever set this anywhere? Oh, okay, this is what we were setting up here. So it was doing some potentially decryption of a string somewhere, doing some weird shifts on the actual bytes inside of the string. So maybe that was what was happening here. And then we're passing it into this function over here. Okay. Let me see if I can see what we're doing here. Passing it to another function. What's this doing? Looks like it's just swapping the value of two parameters right here. So we have our uvar equals a pointer to param1 equals param2, and now param2 equals var1. So this is just swapping two values. So I'm going to call this swap values. So it's swapping two pointer values, looks like. Make sure I'm in full screen here. There we go. Okay, looks like we're doing some string manipulation, then swapping these values. See if I can go back. This is the same function. So we're taking, so this is going to be the length of the new string that we have. And then this is going to be probably the location that's going to be taking the string. Let me move on. What is this method right here? Okay, internet address change routine. Converts the internet host address from IPv4 numbers and dots notation into binary. Okay, simple enough. And then what's the return value? Let me see if I can. Returns non-zero. Let me see if that's the correct return. NTOA. Returns, so it's just going to be that string in binary that it's returning, that it took the IPv4 address in, and then is returning the number in binary. So what was the argument to this? The argument to this was the actual, should be the IP address that it's converting. So this is going to be the in address as a structure. Let me rename that. Okay, looks good. What was this? This was just returning the value from the function. Oh, I think I missed this function. Okay, we're using this string, just try it. I can't remember what this string was. Let me see if I can find the references to it. Here we go. That was it right there. It was this, just try it as a string. Well, that's really interesting. Okay. It's telling me how to live my life, I think. Okay, let's see. We have just try it as a string. This is getting the length. Var string length. Mem compare. Just try it to the parameter that's provided. So this is going to be the result of mem compare. Mem cmp result. So it's seeing if these two strings are the same. So this one string as a parameter and then this just try it string for some reason. Let me just say arg string to test. Okay, we've got our result. If it's the same, we're going to return 0. Let's just call this ret val. And it looks like we're going to be returning whether this string equals just try it or this sock TCP that we had already labeled as well. So let me see what I can name this. That makes sense. Let's do malware test try it sock TCP. I don't know, kind of a funny non-descriptive name. Let me see if I can add the word string to it. Maybe if I do that, it makes more sense. Hopefully I remember that. Okay, so really simple. It's just testing to see that string. We go back. Oh, come on, go back. See if I can get references to wherever we were. I think this was the function we were in. Okay. So this is going to be the result of that. I'll do var. Let's do test string result. And then another one, because we can't just have one variable. Let's do test string result 2. So more just setting up our socket connection, I think. String copy. Again, we have converting the address to binary. String copy that into our local right here. So we'll do var, and this was our sock address in binary. Since it's copying the return value of this into source, then source string copy into this right here. Okay, we have our socket. Okay, and then we're calling this function. We have our socket address, and then this htons. What was this doing again? Htons. Okay, that's just messing with the byte order for the network connection. Oops. And then passing it to this function. Oh, we got another long one. Okay. And a lot of strings. That's what I like to see. Okay. This is interesting, and it looks like it's sleeping. Maybe it's communicating with the socket. Let me label what this was. This was, I think, our socket address. Yeah. I'm gonna call this sock address binary. Then this was our htons. I don't know if I'm pronouncing that right, but that's okay. And then we have arg. We'll do this, we'll start that. Sounds good. We have a lot of local variables. And I think we had a lot of strings as well. Yep. So a lot of these aren't really like local variables, they're just character arrays, but it's not really decompiling properly as a string like we want, so we can go through and fix the types of this to be a character array so that it actually looks a lot nicer. Let me do that. What was this? Nothing super interesting. This hasn't been set to anything yet. Just some initialization. Let's look at strings. I like strings. So I'm looking for the null character, just as an FYI to what I'm doing. So the null character is going to signify the end of a string, and anything in between this is going to be part of the character array. So I find that, and that's how I think I should be separating out the strings. Hopefully I didn't miss one. I think that's good. Oh, that's a long string. Keep going. Okay, starts with a slash, so probably a directory. Let me just paste this into here. Looks like we've got 86 characters. So I'm going to change this into an 86 character string or char array. We do change retype. I'm going to change that to 86. Cool, looks like some command. Let me see if I can fix this. Okay. Long string. looks like some shell command, maybe? Can't read it like this. Let's do our magical regular expressions one more time. Replace. And change this to normal. And, oh, that's hard to read. Looks like we've got some format specifiers. So the %s right there, this is probably going to be part of a string copy or something like that. Ooh, I like this command. Setting IPTables, nice. Okay, pre-routing, TCP connection, destination port. So it's redirecting. This is a golden find. I am very happy we found this. Let me add this in as a comment. Oops. Okay. Oh, that didn't go where I wanted it. Let me see. Let me comment. Okay, there we go. So that's what this string is doing. I'm gonna name this. Let's call this var IPTables and then set. Ooh, I like that command. Okay, we got more strings here, so I'm going to continue on and maybe label these, and then we'll see how these are used over in this function down here. Nice. So this is our socket address in binary, and it's probably doing some communication or waiting until the IPTables set. Looks good. But I think I will pause for this video right here, and we'll continue this function in the next video, and this is looking really exciting, and looks like we're getting to the actual core functionality of the code. So thanks so much for watching laurieWIRED, everyone. In this video, we went through and we continued our analysis of the BPFDoor malware. We found some interesting strings that look like they're setting up a socket connection and setting some IPTables rules. So in the next video, we'll continue our analysis of that function and see if we can find any more of the potentially malicious behavior. So thanks so much for watching laurieWIRED, everyone, and I'll catch you in the next video.